To find these indefinite integrals, or antiderivatives, we're going to need to use some properties. We have a property that says the antiderivative of cosine is sine. Using that property, we'll have the antiderivative of 12 cosine x as 12 sine x. We have another rule that says the antiderivative of sine is a negative cosine. So when we integrate 5 sine x, we'll call that negative 5 cosine x plus c. Let's not stop a good thing. To find the indefinite integral of secant squared x and 3 sine x, we're going to use a couple of properties. The antiderivative of secant squared x is tangent x, and we know that the antiderivative of sine x is negative cosine x. So when we integrate the secant squared, that is the tangent of that angle. And again, the antiderivative of sine is negative cosine, so the antiderivative of 3 sine is negative 3 cosine x, and we'll add that constant of integration. One more. Before we get on to finding this indefinite integral, let's simplify and call this the antiderivative of cosecant x cotangent x. Take away cosecant times cosecant, which is cosecant squared of that angle in the direction of x. One of our properties says that the antiderivative of cosecant cotangent is negative cosecant. Using that, we'll have negative cosecant of that angle. We do have a rule that says the antiderivative of just the cosecant squared is a negative cotangent. But what we see is a minus that antiderivative of negative cosecant, of cosecant squared. That's a double negative, and it's going to turn out positive, plus the constant of integration. So we do have the opposite of the cosecant of x plus the cotangent of x plus c, and that's enough.